Hello, laser geeks. In the last video, the HDPE welding segment was a bit too short, but that's the nature of laser welding. Everything happens fast, except for the weld beads themselves. Laser welding is a very quick process. This time I decided to run a longer HDPE experiment, and we'll add another test in the same video. I'm going to take a piece of 1/8 inch tubing, set the machine to maximum capacity, and start laying beads at 65 centimeters per minute. From there, I'll keep increasing the travel speed until we reach the point where the beam no longer penetrates the aluminum.
Let me see. Okay.
This time I decided to run a longer HDPE experiment, and we'll add another test in the same video. I'm going to take a piece of 1/8 inch tubing, set the machine to maximum capacity, and start laying beads at 65 centimeters per minute. From there, I'll keep increasing the travel speed until we reach the point where the beam no longer penetrates the aluminum.
I still have to cut one more piece. So let's do something else. That was too short. It's not nice, but I can take it out for sure. If I fuck. Okay. Is familiar with the IPG? It doesn't mean nothing when it's flashing. I'm gonna $50, blah blah blah. The main thing is, like, in theory, this is not even the factory aluminum setting, but I overrate it with my personal setup. So, oh, this is the most important part. Wire 65. Let me see. Tube, all right. Okay. Clip this. Right there. I want to see it too. Let me run another one. Actually, let me do 7. I'm going to go up to 70 now. 70. I should move this a little bit differently. Give me a minute. Like so. I mean, when I came all the way to the end, I can see it blow through. I'm trying to get to, I don't know how the hell he had to keep lowering his speed. So my handle parallel to the force. Now we're at 70. I can hear it still blow through. Okay, let's go 75. There we go, 75. Okay, 75. Right there. Okay. So 70. Let's see what still blow too. I can hear it again. It went through. I don't know for how long we should do this exercise. Let's reach the point. No, it's not going to go through. So I'm going to go 80. So I'm increasing the travel speed basically. Whoever knows it, they know. I mean, most people that are watching this channel, they know what I'm doing. Increasing the travel speed. And I'm going to turn. So the 80 is going to get a new side. I'm going to get a flashlight and we're going to look into the tube. Right, 80. Come on, let's see. 80. Right there. A little bit over here. Alright. Still going through. I can hear the sound. That's the reason I dropped the tube, so I can listen to it. And also I don't have to do a crazy setup. So 80 still went up. We went through. Let's do 85. So look, now we are 85 centimeter per minute. Okay. 1/8 thick aluminum tubing. It's pretty much just like a butt joint when I'm doing, so no different whatsoever. Oh, come on. So still burning through 80. Later on we're gonna look around in the tube. I'm not gonna keep turning the camera. Now I'm going 90. Okay, up 90. 90. Still punching through. I mean, you can see the spark inside. I can see it too. Okay, we're gonna go 95. 95. There we go. Still punching through. So we are pretty much around 1 meter per minute speed. And I ran out of space, so I'm going to turn one more time. I'm going to show you guys. It's 95. So 95. It's gonna go quite high. So right now, I think, 4 times faster than when he achieved the full penetration. And I'm still growing through. Oh my God, it's hot. Okay. So we go 100. 100. Still boiling here. Let's go 105. At one point, it shouldn't go through because there's not going to be no dwell time. I'm gonna go 150. Okay, 115.
The phone battery went dark, so I switched to my old camcorder, added a UV filter, and kept rolling. We're now running over 100 centimeters per minute, and the beam still cuts through the material like paper.
So I ran into the issue. My battery died. I don't know exactly where because phone is dead. So whatever was it, we're gonna go from there. So the last test was 150. Now we're gonna go 125. I'm gonna show you 125. Okay. You see, everything more camera. So how fast do I have to go? Still is not gonna punch through. It's still punching through. Yeah, stop 125. I'm gonna go 135. Okay, 135 it is. Still punching through, right? I can hear the noise. We go 145. Not gonna screw around. 145. If you find the speed, it's still punching through. 145. So almost 1.5 meter per minute, and you're still punching through 1/8 aluminum. So I'm gonna go 155. 155. Let me show you next. 155. 155. Nothing changed. That I already have. So ER22, when you don't have positive pressure in your gun because stingy with the gas. 155, let's try. Oh my God, it's so fast, and it's still punching through. I'm gonna come closer a little bit, so we're gonna have a better shot on it. 155. We go 165. I'm getting hungry, so 165 is the next one. I can hear the noise, so we go through. I can see the sparks inside. You know, 175.
I've maxed out my old wire feeder. We're running at 175 centimeters per minute. One thing to note, as far as I know, the X tool is rated to weld 1/8 inch material, only up to 120 centimeters per minute. We've blown past that spec by nearly 50%. Leave me a comment if I'm wrong about the X tool 120 centimeter spec. I just overheard that, so I'm not sure about it. Now there's another task. I need to hack the wire feeder firmware to push it faster. I know this machine can do more, so why leave it stuck at the factory limit? I promised we'd go as far as possible without blowing through, and we've now hit the ceiling of the feeder.
This tube was the slower speed. Okay. Let's check another one. That was the higher settings. See? All the way. All of them. One of these was already 175 or something like that. So it was like 145, 55, 60, something like that.
I placed this 1/8 inch steel tube on the table, not going to replace the wire.
Only it's stainless steel.
I just shot off the wire feeder. 5053 wire. Does not work on a 36 steel tubing. We going to tack, but I know it will blow true, so we will keep lowering the power until it won't. We are starting at 1,500 and keep going down.
Oops. Blasted through. Okay. You can play with this. I have a little bit thicker.
960 is the magic number. It did not go true anymore. I also brought a regular steel tube, but it's partially off camera, so I had to edit it out. How about if we do a little Coke can experiment as well? Let's start to set it up. Step 1, I have to tape 2 cans together, so I can insert it into the turning rig. Then I will tack and run a few passes.
So here is another can. I'm gonna take it first. So freaking small. If I press it too much, it's gonna disalign. It's very hard, very difficult. Let me see. Let's try this. Oops. Doesn't like it. run a couple more passes because it doesn't align perfectly, and I want to get it 100%. By the way, I'm running 170. About 1.5 millimeter scan, something like that. Now I'm gonna bring my new drummer. Okay, I know when I'm gonna take it out. I'm just gonna. I don't know, I did like 3, 4, 5 passes. Let me slow it down. But since it's a fusion welding, right? No wire. You see pinholes, obviously, because my alignment is not perfect. So it's very hard to align these fuckers. If you watch the edge, look at the edge. So it deviates. That's why we're getting the pinholes. So if somehow I would be able to align it 100% perfect, we would not have any pinholes whatsoever. 0 pinholes. But I could try. Why not? Why not? Let's keep experimenting with this. It's not my first scan. I did a bunch of them. But as I said, I need a cotton candy besides welding some. The thing is, so let's see. At 150, this fucker didn't want to shoot. Didn't want to fire at all. So let's try. Let me set up some angle. Yeah. Okay. I did one more cheat. I'm trying to get rid of the pinhole basically. I'm not sure I will be able to get because we don't have so much material to begin with. If I could leave, I don't know. just even more pinholes. It's gonna be strong, you know. I'm sure you. So, I mean, strong enough relative. So first step. Good, huh? So filler wire would help. This power, even the thin what we can put in these machines, the wire feeders, is not gonna melt because I made a test. Okay.
My soda can did not hold much. The base material got way too many tiny holes and weakened the can. The can is about 1/10 of a millimeter thick, so no wonder there. We will get back to this. The main issue is you want to run now smaller than 100 micron. For such thin material, I have to recommission my other laser welding machine, and we will get back to this. I had a few other tests. Some cans did better than this, but I lost the footage, so cannot show it.
See?
If you like the content, please give us a thumbs up and subscribe. Thanks for watching. See you at the next one.